is 1, z, y is 0. 0.3, x is 1, y is minus 1. 0.4, x is 0, y is minus 1. So now you see, these are the 4 nodal points I imported. When you imported the 4 nodal points, you're going to form a mesh, visual insert element. The element you choose quadrilateral 4, then you're going to find an element. This element have a dimension of 1 meter long and 1 meter wide. Move to here, right click. You choose the plate, fill none, outline lighting. Can you see it? Plate, fill none, outline is lighting. This is more like our geometrical model. When you finish this first element, what do? You're going to divide it. Divide it, visual, tool, mesh, subdivide, and you're going to choose it. Something not working. Okay. How I'm going to divide it? I want to divide it into 2 rows. Or 2 columns. A is 2, B is 1. That's what I got. Then I want to get this element smaller. I'm going to move. So, visual, tool, and then move. Can you see it? Visual, tool, move. I'm going to move by increment. Visual, tool, move, increment. Move this direction. So I want to move here backwards in this direction. So I imported as 0.25. After I define the movement, I'm going to choose the point to be moved. So I choose this 2 points, move it. That's what I want. Here, if I choose the element, I'm going to move the element. I don't want to move the element, I only want to move the points. Then I choose the nodal points only. So you undo it, and you choose the points. Okay, that's what you got. I have this kind of element. Then I import the nodal point. Okay? Why I choose that nodal point? Because I want to form that element. How to form that element? I need to think about it. I need to work out. I work out the solution. The solution is that coordinate points. Okay? From visual insert nodal, you got a nodal point. 3.75, 0, 1 point. The second point, 0, minus 4.5. And then one more point, 3.75, minus 4.5. Why? Why it is 3.75? Why is minus 5? This is I calculated. I want to have this mesh, and I worked out the detail is 7.5, or is 3.75, is minus 4.5. So if you want to form this mesh, you need to figure out what mesh you want to form and how much it is. So you need to calculate it. It might take you 10 minutes, or it might take you 10 hours. Okay? You got it? And then I have another point, is more complicated, 1.875 minus 4.5. Okay? I formed it, I want to see what it is. F3 is what it is. Look, so, I missed that point. It should be minus 4.5. I did not got it. Okay? I need to import a new point. Because this one should be 1.875 minus 4.5. Okay? F3, that's what I call it. I imported this point. I still miss another point. Okay, I re-import it again. I imported the coordinates of the points. You see the value of the coordinates when applied. These are the points. I still miss a point. Okay, I imported this point, this point, this point, and this point. After I import this point, what I'm going to do? I'm going to form the element. Form the element by element. So your visual insert element, the element you choose the quadrilateral for. You got it? Anyone want me to stop anyway? This is overall geometrical model. We want to form this kind of model in the end. Okay? Everyone got it? Okay? So what do you do? We're going to go to Visual, Tool, Mesh, Subdivide. And we're going to choose this one. Divide into two rows. So A is 1, B is 2. Huh?
11.
Yeah, you're correct. So sometimes you're lucky if you make a mistake, you can see it. Then what you're going to do, we're going to choose this one, make 3 times 3. Okay? Now, the next thing we're going to do, we're going to form this, what you can see here is a transition element. How to form a transition element? We're going to cut off these two elements. So you can choose elements, choose it, cut it. And then what do you do? You're going to import two critical nodal points and then form the element. So I worked out, I calculated, I found that the critical nodal point has the element a coordinate value of this value. Okay? Is 0.625 minus 0.1687. Another one is 0.625. 0.333. 0.625 minus 0.333. That's what you got. You import these 2 points and then you can form the transition element. So visual insert element, quadrilateral 4 like this, then you link them together. Make sure you form all the 4 elements, okay? This is one way to form the transition element. It is a simple, straightforward, direct method. There are many other methods can be better, more efficient, more colorful, more time. But I show you the basic one, you can do it, okay? You learn one method, you can start with this method, and have as many other better methods as you want, okay? Why I choose other points, not coordinate? Because I calculated. If I want this kind of transition element, I need this kind of coordinates. So you need to sit down with a piece of paper, work out the details. Now, the same for this transition element. Insert nodal, the point is 0.16667. Okay. After you import these 2 points, you can form the transition element manually. Visual insert element. This is element. This is one method. There are many other methods. Okay. You are encouraged to do the other method. Can you see it now? More and more close to what? More and more close to our mesh. So now we're going to further subdivide. Visual, tool, mesh, subdivide. I'm going to choose this one and divide it into 3 and 1. Oh, no, 1 and 3. Yeah, that's what we want. You choose this one, you can do 1 and 3. Oh, that's good. And then you choose this 2, you make 1 and 2. Okay? For this one, the same, you can choose 3 and 2. No. Oh. So now you have formed the FEM geometry model. The details, if you know the basic step, you can figure out the details later. Okay? When you finish the FEM geometry model, the one important thing to do is to check your FEM geometry model. So FEM geometry model must be checked. How to check it? Visual tool, clean. You clean the mesh, say that. Yes, clean. And then visual tool, clean, geometry, say clean. Okay? And there are some other check as well. After you finish the FEM geometry model, after you check it, you're going to import the boundary condition. The boundary condition will start now. Visual attribute, nodal, Wistron. We're going to enter the base boundary condition first. That is, no displacement in x direction, no displacement in y direction. So x is 0, y is 0. Okay? After you select it, you select all the base nodal point, apply. Then you choose the set boundary condition. X is 0, y is free. When you take it off, it's free. So in these conditions, x is fixed, no displacement. Y is not fixed, it can move freely. This is what you got. You do the same for the axis symmetrical points. Choose all the points and import it. Now, the same. You need to import the loading. Loading is push the footing down horizontally uniformly. So element 1, 2, 3, these 3 elements are the elements right underneath the footing. So the displacement of footing is the displacement for the elements for these 3 elements. So it is x direction 0, y direction minus 0.1. Apply. Okay, with this done, you have imported the boundary condition. After imported boundary condition, you're going to import the material property. Import the material property from visual, global, you choose property. When you use this one, you need to choose this plate. Okay? When you choose the plate, you need to choose this one, plane strain, isotropic. Material, you need to import the material Young's modulus with a 10 megapascal, that's 10 million pascal, 10 million. 6. Poisson's ratio, Angevin 0.49. This is for the material part. You need to go to nonlinear. Now we are going to have a nonlinear model. So what do you do? Material, you choose elastic plastic. If you go to nonlinear elastic plastic model, go to material elastic plastic. Yield criterion, you choose more Coulomb. You got it? In the yield criterion, you choose more Coulomb, and you import the cohesion. Cohesion is 100 kilopascal, so it's 100,000 pascal. Friction angle is 0. Damping, no, you forgot about it. Table, not important. Thickness, you must import 1 meter. If you don't import thickness, your FGM will not work. Okay? When you finish this one, you need to go to solver. This is a material property. When you finish material property, you're going to solve it. Go to solver. Okay. First row, solver. In the solver, because it's a nonlinear problem, you need to choose nonlinear static. You see it? Choosing nonlinear static. Load, you need to apply the load. Apply load by increment. Can you see here? You add the load increment. You can add almost increment as you want. The first one is 0.01. The second one 0.05. The third one is 0.1.
little.
Okay, you need import the load, and you need to choose what result you want. Okay, in your shopping list, you want the plane string as well. Now, I think I missed a point. For nonlinear static material property, you need to always choose, tick off nonlinear geometry. It's too complicated. Only choose nonlinear material, okay? Okay. When you have done this one, you could solve it. Save it. Okay, you see it's no error, no warning. That means the computation has done successfully. When you finish the computation, you want the result is stored some way. You need to bring out the result. So you go to result, open it. This is the one. Then you go to the result. Go to the result, choose the scale, 10%. That's what you got. Not bad. Animation. Okay. If you can do this by